Hello everyone, welcome back to my channel. Today we are just gonna start a new chapter, that is the frequency response and control system. There are mainly three, that is the Bode plot, polar plot and Nyquist plot. Today I'm gonna start with the Bode plot. Polar plot and Nyquist plot will come in few days. So now let's get started with the Bode plot. Today let's discuss about the Bode plots. Before getting into the Bode plots detail, let's see some basics about it. So firstly about the decade scale. Decade scale is always in the powers of 10. If we take on the x-axis 1, then it is of course next is 10, then it is 10 square, that is 100, then comes 10 cube and so on. And here it is 0.1, 0.01 and so on. This is about the decade scale. Next comes the octave scale. Octave scale, don't confuse this with the octet scale. Octet scale is always in the powers of 2, but octave scale is in multiplication of 2. This is into 2. So if you represent on the x-axis, it is 1, 2, 4, 8 and so on. And here it is 0.5, 0.25 and so on. Now how to convert this decade into octave or octave into decade? There is one formula which you have to remember. Don't just go into the derivations, which is not required. So conversion. That this conversion is also called as slope conversion. So this is 20 decibels per decade can be represented as 6.02 decibel per octave. This is quite important. You just remember this. Now the example is, obtain the Bode magnitude plot of g of s is equals to 1000 into s plus 1 divided by s plus 0.1 into s plus 10. So we can now find that there is 1 0, the above part, numerator, which is 0, and here there are two poles. Now we have to just ensure that this should be always in the time constant form. So now I'm just converting this part into time constant form. Time constant form is nothing but in the form of 1 plus ts. So but excluding this, these two are not in time constant form. So I'm just converting them into time constant form. So 1000 into s plus 1 divided by 0.1. I'm just taking common, and from here I'm taking 10 as common. So here it will become s by 0.1 plus 1 into s by 10 plus 1. Don't forget to convert into time constant form, because it will lead to entirely different answer if you do not convert it. So cancelling these two. So now we can find that this is in time constant form. So t is nothing but 1 by 0.1, which is nothing but 10 here, and for here it is 0.1. The T2 is 0.1. So it is 1000 into s plus 1 divided by 10s plus 1 into 0.1 s plus 1. So now this is in time constant form. Now we can just go into the next part. Next part is we have to draw the Bode plot. So for drawing the Bode plot, here we have some magnitude, that is 1000, right? So 1000, how can we express this? We can express this in the form of 20 log 1000. So 20 log 1000. Why am I converting this? Because we need this in the form of decibels. So if we need in the form of decibels, we are converting it into, we are taking it in the log magnitude scale. So it is 20 into log 10 power 3, which is 20 into 3 log 10, which is 60 decibels. So 60 decibel means in the graph, it will start here. Here it is 60 decibels. So the magnitude part is done. Now let's go into the zero part. So 0 is S plus 1. So S plus 1, always a 0 part. 0 will always move upward in the Bode plot. So this will be like this. From some part, it will move upward always. It will move upward. And the poles part, taking S plus 10S plus 1. Pole part will always move downward. So if it is here, then it will always move downward. Okay. So whatever I have told, I'll just summarize it again. For the Bode plot, we have to consider this in the time constant form. I'm converting into time constant form. And if there is a magnitude, convert it into a decibels form. Then mark the decibels. And if there are zeros, we have to move upward. And if there are poles, we have to move downward. Now I'm just plotting the entire thing on the XY axis. So it will start from 60 decibels because 1000 I have converted into 60. So it will start from 60 decibels. Now there's a pole at 10 and there is also a pole at 0.1. So at 0.1 there is one pole, at 10 there is one pole, and 1 there is one 0. This I got to know from 1 plus TS, that is T part I'm going to mark on the x-axis. From that I got to know. So here it is, one pole is 0.1 and next one is 10 is 1 and next again a pole which is at 10. So now on the log magnitude scale, the first one is a pole. So if it is a pole, I told you it will move downward. So here from 0 till 0.1, it's a straight line. And from 0.1, it will move downward till 1. That is how much? That is by minus 20 dB. So here it will be 40 dB. From 60 dB it will move to the 40 dB. Now again at 1 there is a 0. So if it is a 0, then it will move upward, right? But since it has already moved downward, here again it can't raise upward directly. If it has to raise upward directly, there has to be 2 zeros. So but at S plus 1 there is only 1 0. So I'm going to take a straight line. From here it's a straight line. If there was another 0 here, if it was S plus 1 the whole square, it would have moved upward. Else it is a straight line till 10. And from 10, it is again downward because it's a pole at 10. So it will move downward. So this is the Bode magnitude plot. If there was another pole, it will further move downward. Here it is moved by minus 20 dB. So it is reduced to 20 dB here, and here it is on the since it's a log scale, here it is 100. If you think the video was useful for you, don't forget to like, share and subscribe. Thank you.